Hi everyone, today we're going to discuss measuring segments and angles. For today's warm-up, place 10 dishes along 4 edges of a table so that each edge has the same number of dishes. Yes, it can be done. Take a moment and try it on your own, and then hit play to see if your answer corresponds with mine. The trick here is to use the corners. If you have a plate located on the corner of the table, it actually represents a plate on 2 separate edges. So we have 3 plates along this edge, 3 plates along this edge, 3 plates along this edge, and 3 plates along this edge. As we move forward with today's lesson, I want you to think about how the properties of segments and angles are actually used to determine their measurements. On a freshwater fishing trip, you catch the fish below. By law, you must release any fish less than 12 inches long. You need to measure your fish, but the front of your ruler on your boat has worn away. Can you keep your fish? Explain how you arrived at your answer. The key here is to realize that we do not need to start at 0 on our ruler to get an accurate reading. As long as we take our fish and we place it on the ruler where we can see the numbers, and we subtract the 2 values, and then take the absolute value of those values, we will determine our answer. Keep in mind, it doesn't matter if I subtract 18 from 25 or 25 from 18, because I'm going to be taking the absolute value of my result, which will always give me a positive measurement. So can we keep this fish? The answer is no. So what are some methods for finding the distance between A and B? One method is simply to count. If we start at -3 and we count to 5, we can see here that there's 8 spaces. However, when the numbers get more complicated, it's much easier to use a more mathematical approach. The best way of doing this is to label the 2 values, subtract them, and make sure that you take the absolute value of that answer. Now, why do we use absolute value when we're dealing with measurement? You can't have negative measurement. An absolute value will always give us a positive result. So it's important to consider and always remember to do. Refer to the figure below. What is the length of AC? Now remember, it doesn't matter if you choose to use the A first as your value or the C first as your value. So you could start with -3 or 1. Because we're subtracting them and then taking the absolute value, we will always obtain a positive result. As you can see here, I first chose to use -3 subtract by the +1, and I got the absolute value of -4, which yields a distance of 4. If you chose to do the other way, let's say you chose to do 1 subtract -3, you'll get the absolute value of +4, which is also 4. So the distance between -3 and 1 is 1, 2, 3, 4 spaces. Now use the same method to find the length of CD. You should have found 3 to be your result. Now in your own words, which strategy would you choose to find the distance between any 2 points on a number line? This slide just highlights what we just discussed. It says find the measure of AB. To do that, we could do the absolute value of our coordinate A minus B, or we could do the absolute value of the coordinate B minus A. Either way, we'll get the result of 5. A term that we're going to hear throughout the course of geometry is a postulate. A postulate is a statement that is assumed to be true. Our main focus for this lesson is called the segment addition postulate. And what that means is, if you have 2 segments, here we have A, B, and we have BC, then AB plus BC will equal AC. Recall from our previous notes that collinear means lying on the same line, and coplanar is lying on the same plane. Okay, let's try an example of the segment addition postulate. Points F, G, and H are collinear. If GH is equal to 16, what is FH? To do this, we need to recognize that our 2 smaller segments, FG and GH, together will equal the large segment of FH. My first step in this problem is to find a value for x. It states that GH is equal to 16. So I can simply take 2x plus 2 and set it equal to 16 to solve for x. So 2x plus 2 is equal to 16. If I subtract 2 from both sides, I get that 2x is equal to 14, so therefore x must equal 7. So now I can take this value and plug it in for my other x value over here, and then I can find the length of FG. As you can see here, I have 3x minus 1 as the length of FG. I plugged in 7 for the value of x. That gives me 3 times 7 minus 1, which is 21 minus 1, which gives me a value of 20. So now I know that the length of FG is equal to 20. So now in order to find the entire length of FH, I just need to add together 20 and 16, and that gives me my final result of 36. This slide reviews the problem we just did a little more formally. As you can see, GH is equal to 16. So we're going to substitute the value of GH in for GH, which is 2x plus 2. And then we're going to solve and we get x is equal to 7. Now the segment addition postulate says the smaller segment plus the other small segment is equal to the larger segment. So this just formally sets it up, and we know that FG plus GH all together is 3x minus 1 and 2x plus 2. So that gives us 5x plus 1 altogether. We found the value of x is equal to 7, so we know that 5 times 7 plus 1 is equal to 36, which was the result we got. So keep in mind, a lot of times there's a number of approaches to solving mathematical equations and problems correctly. They do not always have to be the same. However, what is really important to note is that the initial steps of these problems are the most important. You want to make sure that you're setting up equations that are equivalent. For instance, we know that 2x plus 2 is equal to 16. It's really important we set that up correctly because that leads the way for the rest of the problem. A common error is sometimes you just solve for the variable of x when the problem is actually asking you for something else. In this case, it's asking you to find FH. So make sure after you find the value of x, you really look for what the problem is actually asking, which will often require you to plug in that value of x to get the final solution. Let's try another example. Here, Km is equal to 67. What is the value of Lm? See if you can try this one on your own, and then compare your result with mine. For this problem, I know that 4x plus 7 plus 5x minus 12 is equal to the entire value of 67 units. So I just set up an equation where I have 4x plus 7 and then 5x minus 12, and that's equal to 67. Now we just solve for x by combining like terms and isolating the variable. So after combining like terms, I have 9x minus 5 is equal to 67. Add 5 to both sides. Then I get 9x is equal to 72. Divide by 9, and that yields x is equal to 8. Now that I have my x value, I can take that and go back to the original question to see what they're asking. And as you can see, it says, what is the value of Lm? So I want to take my x value and plug it in for the x value of Lm, and then I can solve and find how many units long that measurement is. So here I have 5x minus 12 is equal to Lm. I plugged in 8 for my value of x, so 5 times 8 minus 12, and that gives us 40 minus 12, which is equal to 28. So our final solution should be 28 units. Here we have the same problem written more formally. Here we have KL plus LM is equal to 67. And we know that the value of LM is 5x minus 12, so that can be substituted in for LM. We also know the value of KL is 4x plus 7, so that's substituted in for KL. And then when we solve, we get x is equal to 8. After we have that value of 8, we have to go back and plug it into our original value, and we get 28. Try these two on your own, and then hit play and see if your answer corresponds with mine. As you can see, the first thing I did here, it took my value of 4x plus 3, and I set it equal to 15 because in the problem it indicated that AB was equal to 15. So I made sure that AB was equal to 15. From here I was able to solve, so I know that 4x plus 3 equals 15. Subtract 3 from both sides. That gives me 4x equals 12. Divide both sides by 4, and that gives me my value of x as x equals to 3. So now I had to be careful because the question is actually stating what is the value of AC. So I want to know this entire value here. Well, now that I know the value of x, I can simply plug in my value of x here. So I know that x is 3, so 2 times 3 would be the length of BC, which ends up being 6. So now I know that BC is equal to 6, and AB is equal to 15. So if I need to know the entire length, I know that 15 plus 6 gives me 21. In this problem, it states that AC is equal to 36, so I made sure I labeled that first. And if you remember the segment addition postulate, we know that the little segment plus the other little segment is going to be equal to the entire segment. So I set that up in equation form. I have 3x plus 6 plus x plus 2 is equal to the total of 36. And now I just have to solve for the missing variable, which is x. So combining like terms gives me 4x plus 8 is equal to 36. Then I have to subtract 8 from both sides. So that gives me 4x is equal to 28. And then I need to divide both sides by 4, and that yields x is equal to 7. Now, since I'm looking for the value of AB, I have to take the value of 7 and plug it into my expression for AB. And I know that AB is equal to 3x plus 6. I'm going to substitute 7 in for x, so I know that AB is equal to 3 times 7 plus 6, which gives me my final answer of 27. Okay, for our last question today, we're going to use the segment addition postulate to help us solve this algebraic application problem. Towns X, Y, and Z are located along a straight highway. Town Y is between X and Z, and the distance from X to Z is 56 miles. YZ is 4 miles more than 3 times XY. Determine the distance from town Y to town Z. So our best approach to this problem is to draw a picture. So I'd like you to take a moment and reread this problem and draw a picture that corresponds with the problem. So as you can see, I labeled towns X, Y, and Z with Y in between X and Z, and the distance from X to Z is 56 miles. So now I'm going to try to set up an equation using the information from the rest of the problem. So it says YZ is 4 more than 3 times XY. Well, we don't know what XY is, so let's call it W, just because we don't know it. So let's give it an unknown variable that's not represented in front of us. And it says YZ is 4 more than 3 times XY. So we know that it's 4 more than 3 times whatever W must be. So now I've set up in a scenario where I'm able to use the segment addition postulate and do this first little segment plus the second segment is equal to the entire thing, and I can solve for the missing variable. So now I know that W plus 3W plus 4 is equal to 56. If I combine like terms, I have 4W plus 4 is equal to 56. Then if I subtract 4 from both sides, I get 4W is equal to 52. After dividing both sides by 4, I'll get my final result of W is equal to 13. At this point, I reread the problem and I see that I need to determine the distance from town Y to town Z. So town Y to town Z is represented by 3W plus 4. So now I just simply have to take my value for W and substitute it in for the W in the XY part of the equation, and I get 3 times 13 plus 4, which yields my final result of 43, and the units is miles. Thanks for tuning in. I hope you guys have a great day.